talking about the second problem here. It is a little bit more challenging. It seems easy at first, but we're going to make sure we're reading carefully. It says triangle A has side lengths that measure 4 inches, 5 inches, and 6 inches. Triangle B has sides that measure 8 feet, 10 feet, and 12 feet. Taylor and Landon are discussing whether the two triangles are similar. Do you agree with Taylor or Landon? Taylor says they are similar. If you double each of the side lengths of triangle A, you get the side lengths of triangle B. Landon says they are not similar. Taylor's method works when the two measures have the same units. However, the sides of triangle A are measured in inches and the sides of triangle B are measured in feet. So they cannot be similar. Okay, so if we think through this, right away, I kind of start to agree with Taylor. She's saying you double each of them in A. 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. Okay, so that is true. However, if we think a little bit further in Landon's explanation, he is correct in that the units are not the same. I have inches compared to feet. So what I'm going to do here is convert my feet here to inches and then go in and check to see if they are scaled copies or not. Because right away, I'm agreeing with Landon because the units are not the same. However, I'm not sure if that makes them similar triangles or not. So I'm going to go ahead and draw them in. So I'm going to draw my bigger triangle. Oops, don't know why that curved. Okay, so I'm going to have 8 feet, 10 feet, and 12 feet. And then in my smaller triangle, I'm going to go ahead and draw that in. I'm going to make sure I match up my sides. So I want my smaller sides to be in the same place. So I'm going to put 4 inches here to match my 8. And then my next biggest side is 10 or 5. And then I have 6. So you want to make sure you're going in the same order. But again, I want to make sure that my units are the same. So I don't want this triangle in feet. I'm going to go ahead and convert it to inches. So you're going to need to think about scaling here. So I know that 1 foot is equal to 12 inches. So if I want to figure out for 8 feet, this is what we were doing whenever we were doing scaled copies. If I want to figure out 8 feet, well, what is my scale factor? 1 times 8 takes me to 8. So I can do the same thing here and do 12 times 8. If I multiply 12 times 8, I get 80 plus 16. It's going to be 76 inches. So I'm going to use 76 inches here. I'm going to go ahead and do the same thing. Now I'm talking about 10 feet. My scale factor from 1 foot to 10 feet is 10. So I'm going to go ahead and multiply this by 10. And I get 120. And then I'm going to go ahead and do that same thing. I'm so sorry I have to pause this video because I have to go let my dog out because he has to go. Okay, so to finish that up then, I'm going to find that third side length. So I have 12 feet. My scale factor from 1 to 12 is to multiply by 12. So I'm going to multiply this by 12 down here, and I get 144. So now that I have my side lengths in inches, I can go ahead and find my scale factor. So I'm going to take a pair of corresponding sides, 4 inches to 76 inches, and then 5 inches to 120 inches. And I'm just going to check to see if we get a common number. So 76 divided by 4. If you want to go ahead and use your calculator for that, that is perfectly fine. 76 divided by 4 is going to give you 19. 120 divided by 5 is going to give you 24. So right away, I notice I do not have a common scale factor from 4 to 76 and 5 to 120. So I do agree with Landon, because your scale is different, there is no scale factor. So I'm going to go ahead and circle Landon, and then I'm going to allow my math here to be that explanation for me.